Today we're going to talk about another way to represent statistical situations and statistical data. We're going to talk about Venn diagrams and set theory. So before we do that, let's just talk about a few vocabulary words. So first is a sample space. So a sample space is a set of all the possible outcomes for a chance process. So for example, if I'm rolling like a regular 6-sided die, then I have 6 different outcomes. I roll 1, 2, 3, 4, 5, or 6. The next important vocabulary word is an event or a subset. So that means it's an outcome or a specific set of outcomes from the sample space. So if I'm rolling the dice, then maybe the event that I'm looking for is when I roll a 1, or perhaps it's when I roll an even number. Okay. Now the complement is this next one, and it's notated. We notate it with this little C. It kind of looks like an exponent. That's a C, and that just means not. So it means all the outcome in the sample space that are not part of the event. So if I care about the event being me rolling all even numbers, then the complement of that would be rolling an odd number. Okay, let's look at a couple examples, sorry. So we've got this table that has 3 different examples of a chance process, which is basically something that you're going to do. So for example, we could flip a coin, right? If we flip a coin, then the sample space S is equal to the set of heads or tails. Those are your 2 options. You'll notice these curly brackets. We're going to use these brackets to represent a set. And a set just means a list of things. Okay, so you're going to see the curly brackets a lot today. We could name an event or a subset. We could name it B, and we want that to be the event of rolling heads, which means that the complement of B, or everything that's not B, would be the event of rolling tails. Okay. So let's look at the next one. So we've got the roll of a die. So again, if I have the sample space is the possibility of rolling any number 1 through 6. If my event is going to be the even numbers, then the set that I would care about would be the set that includes 2, 4, and 6. And then the complement of that subset or event would be rolling a 1, 3, or 5, which is everything that's not included in the event of even numbers. Okay, I'm going to let you guys go ahead and look at this third example of picking a letter in the word probability. So let's talk about a few other vocabulary words. So we've got this word union. So union is denoted with this symbol right here. It looks like a U. It's actually just a mathematical symbol for a union, and it means or either. So whenever you say like the union of the event A and the event B happening, it means all of the elements that are in A or in B or that are in both of them. So if you look at this Venn diagram on the right, it means that I want everything that's in the A circle, which is already kind of shaded in green, everything that's in the B circle, and I'm going to include all this stuff between that kind of overlaps between A and B. The next important symbol and word is the intersection. So if you take that U symbol that we just learned in union and flip it upside down, kind of looks like an N, that is an intersection. That means that when I use that symbol, I only want the 2 things, anything that's both in A and in B. So I'm looking at the overlap. It is possible that there are some sets that don't have any overlap. If there's no overlap, then you can say that's the empty set, or you can use this symbol, or just kind of draw the brackets and don't put anything inside of them. Okay. Another thing that we can do, sometimes you might want to say, I want to know everything that's in A as long as it's not in B. Okay, so if you look at the Venn diagram on the right, it's like everything that's part of the A circle as long as it's not in the B circle. And there's 2 ways of writing that, and they are right here. It's A intersection B complement, or more commonly A minus B. A minus B basically means take all of A, take away anything that was also part of B, and then what you're left with is going to be what you care about. Okay, let's do some examples. So hopefully we've done a lot with Venn diagrams, but let's just make sure that we're all comfortable with them. So a Venn diagram is just a series of circles that are overlapping. If you look at this Venn diagram right here on the bottom left, we've got an event A and an event B. So basically the left circle means all the data points that pertain to event A, and then the right circles all the data points that pertain to event B. There's a section in the middle that basically denotes data points that are in A and B. And there's also a section on the outside. So this like box on the outside is not just a border. It is actually saying any events that are part of your sample space that are neither A nor B. Okay. Let's go ahead and take a look at shading portions of the Venn diagram to represent very specific situations. So this first thing is A complement. So I want to shade everything that is an A complement, which means it's everything that is not part of A, which means it's going to be everything on the outside here. And it's also going to be everything that's inside of the circle B that doesn't overlap. Okay, so what I've shaded represents the area for A complement. Okay. So in number 2, what I want to look at is A intersection with B complement. So remember, A intersect this little upside down U, that's the intersect sign. That means I want the part that is included, that is like the overlap between A and B. But if I want the complement, it means that I want everything that's not in the overlap of A and B. So the only place that's being overlapped is this place that I'm outlining in the middle. Everything else is part of the complement of that space. Okay. And then number 3 is B minus A. So basically what I'm doing is I'm going to look at everything that's inside the circle B, right? And then I'm going to take away all the pieces that are inside of the circle A. Okay, so basically it's going to leave me with just this portion of the circle that is exclusively B. Okay. So if you had trouble with these, take a moment and go back and kind of just look over them again and try to digest what's happening in each of these examples. And we're going to do some more examples now together, of course. So let's talk about this example. So let's say my chance process, or the thing that I'm doing, is rolling a 10-sided die. So I've got the numbers 1 through 10 on them. We're going to let event A be rolling an odd number and event B be rolling a prime number. So the first thing I want to define is what is the sample space. And we're going to call that S. And I'm going to use my little curly brackets. This is just anything that any outcome I could possibly get from rolling a 10-sided die. So I could roll a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, or a 10. Okay. So with the sample space, I'm just listing all the possible outcomes. Okay. Now I want to list the outcomes of each event. So if I'm just looking at A, what would I have to roll in order for me to say, yep, event A happened? Well, I would have to roll an odd number. So I'd have to roll a 1, a 3, a 5, a 7, or a 9. So what I'm doing here is I'm basically looking at my sample space and picking out the pieces that match the event A. I'm picking out all of the odd numbers. For event B, I am going to pick out all the prime numbers. So remember, a prime number is a number that can only be divided by 1 in itself. 1 is not a prime number. That's kind of your only tricky one. So 2, 3, 5, and 7 are my prime numbers in this set. Okay, so I have 2 events, A and B, and they're based on that sample space that I have. So now what I want to do is I want to draw a Venn diagram that represents the sample space with subsets A and B. So I'm just going to kind of draw kind of the rough outline of a Venn diagram, and then we'll figure out what goes where. Okay. So just go through each number one at a time. So the first item in my sample space is a 1. Now the 1 is part of event A and it's not part of event B. So I'm going to go ahead and put that in my A circle. Now 2, if you'll notice, is in event B but not event A. So I'm going to put that over here in the B circle. 3 is one of my special ones that's it's in the overlap. So 3 is going to go in the space between A and B because it's both in set A and in set B. Then my next number is 4. And 4 is neither in set A nor in set B, so it's just going to kind of float out here on the outskirts of the circles. 5 is in both sets. 6 is in neither set. 7 is in both sets. 8 is in neither set. And then 9 is in event A, and 10 is in neither set. Okay, so that's how you would go ahead and draw a Venn diagram that would represent this situation. Okay, so let's go ahead and use our Venn diagram to answer some questions. So list all of the outcomes in A union B. So remember, A union B is everything that's in A or B or both A and B. So I'm just going to list all the numbers that are in any circle in my Venn diagram. So 1, 2, 3, 5, 7, and 9. The next one is I want to list all the outcomes for A intersection B. So A intersection B is just going to be the overlap. So what's in both A and B? And that's going to be 3, 5, and 7. All right, listing all the outcomes in A complement. So remember, A complement means everything that's not in A. So here I want to list all the numbers that are not in the circle A. So I have 2, 4, 6, 8, and 10. Notice that I do include the overlap. So anything that was in A or in the overlap between A and B is part of A. So I'm just taking all those values that were not in the A circle. Now I'm going to do A union B complement. Okay. So let me just show you one way of doing this, because we've already figured out what A union B is, right? That's what we did up here in example D. If we want the complement, we want anything that's part of the sample space that's not in A union B. Okay, which means, so if we look back at what we listed up here, we have 1, 2, 3, 5, 7, and 9 in A union B. So I'm just going to put the numbers that 1 through 10 that aren't in A union B. So I have 4, 6, 8, and 10. And that is going to be A union B complement. And my final question for this example is I want to list all the outcomes for A minus B, which means I'm going to look at everything that's in A. Let me grab a highlighter. Everything that's inside the A circle. And then I'm going to take away all the things that are also part of B. So I'm basically going to get rid of the 3, 5, and the 7. So the only thing that's in A but not in B is 1 and 9. Okay. So there is another example here in this, if you have the notes. So I'd urge you to go ahead and try to set up a Venn diagram and answer some questions about this one. And go ahead and check your answers with the notes that are posted on Canvas. And I'm going to post one other follow-up video that just shows you how to set up a Venn diagram in another way. So go ahead and look for that video. It'll be just a couple minutes, and it'll help you finish off these notes.